Hey everyone, welcome to this walkthrough. In this video, I'll show you how to build the time series forecasting project in DataRobot from start to finish. Our goal is to forecast future car sales for different car models based on historical data. We'll cover adding our dataset, configuring the time series setup, training models, and finally, reviewing the results. I'm currently inside a new use case that I called car sales forecasting. A use case acts like a workspace. It keeps your datasets, experiments, notebooks, and deployments all in one place. So let's start by adding our dataset. To do this, we'll go to the Data Assets tab. Here, you'll notice that DataRobot gives you several ways to bring your data in. You can connect directly to a database, upload from a local file, or even pull data from a URL. For this example, we'll go with a local file. I'll select my local CSV file that contains monthly sales by car model. As soon as the upload starts, DataRobot begins its first automated exploratory data analysis. While the dataset is being registered, DataRobot automatically analyzes and profiles every feature. It detects data types, transforms date-time features, and assesses feature quality. Once the dataset registration is complete, we can open it to explore what DataRobot uncovered during the first exploratory data analysis phase. Here, we are in the dataset view. Each row here represents a specific car model for a given month, and our main target column is sales volume. That's what we'll be forecasting. We also have the date column, which defines the time sequence, which we will use later when we configure our time-aware settings. Up top, we also see summary statistics that DataRobot generated for each feature. If clicked, you'll see more information such as number of missing values, mean, and median, all automatically generated by DataRobot. So, everything looks good. Let's move ahead and start the modeling process. I'll click Data Actions and Start Modeling. Now, we are on the Modeling Setup page. So let's configure the key settings for this project. For the target, we'll choose sales volume. That's what we're trying to predict or forecast. For the modeling mode, we'll select Comprehensive Autopilot. This allows DataRobot to explore the widest range of modeling approaches. On the right, you can see a summary of the configurations so far. This view updates automatically as we make changes. Now, we'll click on Additional Settings, and then Time Series Modeling. In this project, we will enable Time Series Modeling. You'll notice that DataRobot automatically detects the ordering feature, which defines the sequence of our time-based data. In our case, it's the date column. It also detects the potential series identifiers, which tells DataRobot which records belong to the same group of time series. In this case, it's going to be the model column. DataRobot already recognized that our dataset has a monthly time step, so all the periods are aligned by months. For the feature derivation window, we'll set the values to 13 and 1. This tells DataRobot to use data from 13 months up to 1 month before the forecast point when creating features. Then, for the forecasting window, we'll set it up from 2 to 3 months. That means DataRobot will predict sales 2, 3, and 4 months into the future. It will optimize models based on the performance across that full range. Next, we'll specify the features known in advance. These variables that don't change with the time and already known when making a forecast. In this case, that includes brand and major segment. Now, we can go back to the Data Partitioning tab. When time series modeling is turned on, DataRobot automatically configures date-time partitioning and set up backtests based on your dataset. You can review or customize these settings anytime from the Data Partitioning tab. Now you can also see the full setup summary updated on the right. So everything looks complete now. So let's go ahead and click Start Modeling to begin training our models. DataRobot will automatically derive time-based features, pre-process the data, and begin testing a variety of forecasting models. Once the modeling process finishes, we go to the leaderboard. This is where all trained models are ranked based on performance. Each row here represents a different model that DataRobot tested automatically. The models are sorted by the optimization metric that we selected earlier. In this case, a lower value indicates a better performing model. If we look closely, we can see that DataRobot explored a mix of modeling approaches. Everything from gradient boosting and random forests to specialized time series models. All of these were trained and compared using the same consistent backtesting setup we defined earlier. Now we can explore any model. So let's click on this one to explore it further. There are several tabs here that we can explore, like explanations, performance, and details. Let's start with the Details tab and take a look at the model blueprint. A blueprint is a graphical representation of the full modeling pipeline. It shows all the pre-processing steps, the algorithm used, the post-processing applied to generate the final predictions. This gives us a transparent view of exactly how the model was built from raw data all the way to the final output. Next, we'll go to the Explanation tab. This section provides charts and visuals to help us understand how the model is making its predictions. Let's start with the feature impact. This gives us a high-level visualization of which features have the strongest influence on model decisions. We can also look at the feature effects, which are similar to partial dependence plots. This shows how changes in a single feature's value impact the model predictions. It helps us visualize the relationship between the variable and the forecast. Now, let's switch to the Performance tab. Here, we have a detailed breakdown of the model's accuracy and stability using different plots and metrics. First, let's look at the metric score section. This lets us review the model performance across all supported metrics for specific backtests, across all backtests, and even on the final holdout set. Next, we can look at the lift chart, which compares actual versus predicted values across different ranges of the target variable, giving us a clear sense of how the model tracks real outcomes. And the accuracy over time chart shows how prediction accuracy changes across different time periods based on the selected backtest, the series, and the forecast distance. Altogether, these visuals make it easy to understand not just how accurate the model is, but also why it behaves the way it does. That's it for our time series forecasting walkthrough in DataRobot. We covered how to configure the time-aware settings, kick off the modeling process, and review the results. Thanks for watching.